So question 5 then is the Dijkstra's algorithm question. So we've got the fare that comes to town and sets up rides in 2 large fields that are separated by a river, and then we're being given all of the walking times between the different rides. So 5A part 1 asks us to use Dijkstra's on the diagram to find the minimum walk time from A to every other ride. So just bringing the let's get rid of that one for now. Just bringing that up there then. So Dijkstra's algorithm starts with, and we're starting from A to every other ride. So we're going to put a 0 at A because it takes us no time to walk there. And we're going to box that as well. You don't lose a mark if you don't box the A. So from our newly boxed A then, there are 3 possible routes. We could go for 5 minutes and get to D. So that is coming from A. We could go for 8 minutes and get to C. So it's 8 from A. And we can go 4 minutes to B. So that's 4 from A. So looking at what we've got then, we're going to select the smallest possible, which is the 4. And now from 4, we've got 2 possibilities. We can go across to E, which will be another 12 minutes. So 12 from B there, or we can go up to C. Now 4 plus 2 is 6, which is smaller, so we're going to cross out the 8 from A and replace that as a 6 from B. So my options now, I've got this 5 here, a 6 or a 12. So I'm going to box the next smallest, which is a 5. Now there's 3 routes from 5 from here. I can go down here, but that would cost me 9, and there's already a 6 there, so I'm not going to write down the 9. I could come down this one here, which would cost me 11, so I'm going to cross out the 12 from B there, and I'm going to change that to 11 from D. And then alternative, I can cross the river, and that's going to be 7 from D. So the numbers that I'm now working with are 7, 11, or 6. So the next smallest one is the 6, so I'll box the 6. Now, we've already thought about coming down this route, we'll just check going up there. That's going to cost me 6 plus 4, which is 10, and it's already boxed, so that's not going to be the fastest. There is, however, this route down here coming down the 3. 6 plus 3 is 9, and that is smaller than the 11, so 9 from C there. That's all the options from C. So now I've got a 9 or a 7, so I box the next smallest, so I box the 7 and then think about what I can do from there. I can go 5 along to I, which is going to cost me 12 from F. I could come down to the middle here, which is going to cost me 10 from F. Or I could go straight down here, which is 7 plus 7, so that's going to cost me 14 from F. So I write those ones down there. And now I've got a 9, a 14, a 12, or a 10, so I box the 9. There's no options for me, okay? I can't go back up or can't go any of those. All the other routes are boxed, so I know that that's the quickest. So the fastest way to get from A to E is 9, okay? So coming back over here then, over to the right-hand side now, looking at, I've got my options of 14, 10, and 12, so I'm going to box the 10. So I could go up here, but that would cost me 14 from H, and that's not smaller, so I don't write it down. I can go down here for 15 from H, or I can go down here, and that is going to be quicker than going straight down. That's going to cost me 13 instead of 14 from H there. So now I've got 12, 15, and 13, so I box the 12. Now I can see that actually it's going to be fast. Well, it's not going to be fast, it's going to be the same amount. So some students wrote 15 from I. Okay, it doesn't really matter. Okay, there's not actually, it doesn't matter which way you go. As long as you've got a 15 here, you haven't got anything wrong with the algorithm. So that's that one. Then I've got a 15 or a 13 to box. I'm going to box the 13. Now from there, the only thing I can go to that's not been boxed is straight across here for length 3. That's going to cost me 16, so I don't want to write it there. And then finally, I'm just going to box the 15 there. Okay, so that's how we use Dijkstra's on this diagram, this network, and that's worth 4 marks. Okay, so getting all this correct with all the crossing out that I've done and no more, you will get your 4 marks. Now scrolling back up, write down the route corresponding to the minimum walk from A to G. So where do I want to go? I want to go to G. And this is where writing the labels really helps us. So from G, we go back to H. From H, we go back to F. From F, we go back to D. And then from D, we go back to A. So my route is this one here. And that's why we write down where we've been as well. So the correct answer to this is we start at A. So this is A part 2. It comes from A to D, F, H, and then G. Okay, so that was the fastest way to do that. If you wrote it in reverse, you didn't get the mark. So that was worth 1 more mark there, which is where the 5 marks come from for the first part of this question. Now, scrolling up, we'll have a look at B. So what part B is asking us to do in this question is that there's been this new footbridge that's been put in. So let's draw this in. The new footbridge, so it connects E to G. We're connecting those two there. I'm just going to get rid of this highlight as well so it doesn't confuse us. So we've got this new footbridge that's come in, and it tells us that the time to get to G has been reduced. It reduces the time it gets to G, but the time from A to J has not been reduced. So with this new footbridge, getting to G, so what was 13, it's now less than it. So we've still got to get from A to G. So to do that, we've got to go the 9 that we've already identified. So to get from A to G, we've got to go, if we just do this going backwards, so the 3, the 2, and the 4 there. So that's how I get from A to G. So that costs me 9, or it takes me 9 minutes. So from A to G is 9 plus this new footbridge X. And that is a smaller time than what was A to G. So A to G was 13, so that is strictly less than 13 because it's been reduced. It can't be equal to 13. The time from A to J, though, has not been reduced. So the time has not been reduced. So if I'm taking this route, I'm going to go from A to B to C to E across my new footbridge X plus 3 more to get to J, and that's not been reduced. So when I go the 9 to get to E plus my new X plus the 3 to get from G to J, that must be bigger than or equal to 15. Okay, because it says it's just not been reduced, so it can't be less than, but it can be greater than or equal to. And then we've just got to solve with these inequalities. So these are the 2 inequalities we've got. So if we solve the first one, subtract 9 from both sides, I get X is strictly less than 13 minus 9, which is 4. And from the second one, just tidy that up, I get 12 plus X is strictly greater than or equal to 15. So X is strictly greater than or equal to 15 take away 12, which is 3. And if you just recall from the question, it says that X is an integer, so it's a whole number. So what whole numbers are bigger than or equal to 3 and strictly less than 4? Well, X must equal 3. And so you needed to show either this inequality here or this one here to get 1 mark. Similarly, the 2 inequalities here or here to get the second mark. And then finally, concluding that X is equal to 3 is where we get the 3 marks for this second part of the Dijkstra's question.